Hi, today is September 10th, and we are actually taking a break. We're going to jump into section 9.1 of we're taking a break from the old book. We're jumping into 9.1 of the old book instead of the Big Ideas book, but I'm just going to add it to the new playlist, Big Ideas. I kind of like the way that they break down the topic of 2.5 is broken down into 3 sections in the old book in chapter 9. So this is basically 9.1 in the green book. You'll be doing homework out of 9.1, and the page number is 403, 1 through 46 all for September 10th. All right, today we're talking about sets, and we're looking at intersections and unions. Okay, a set is a collection of members or elements. And one good way to look at this is if we list the members in the following sets. What are the colors of the rainbow? We could say that our members are red, orange, yellow, green, blue, indigo, and violet. If we look at the set of vowels in the alphabet, our members would be, the set is the set of vowels, but the members would be A, E, I, O, and U. Or we could say they're also elements. And if we look at the Beatles, okay, we're looking at the elements, or the members, would be John, Paul, George, and Ringo. So this is what we call elements or members. An example of a set with no members might be a spider with 10 legs. We know that spiders don't have 10 legs, so there's no members in that set. And that's what we would call an empty set. Okay, so when we're doing operations with sets, I've got 3 sets here. An intersection, the symbol we use is like the upside down U or a horseshoe. An intersection is what we call an AND statement. And these are the members that both have in common. We're really talking about the commonalities. So if I looked at the A intersecting B, what is in common? We know that 2 is in common, 4 is in common, and those are the new members of A intersecting B. In that set is 2 and 4. Notice I have it in the braces and not in the parentheses, because if you put it in parentheses, it's a point on a coordinate plane. Now I want you to pause the recording and try and find the intersection of B and C and A and C, number 2 and 3. Pause it. Now check your work. When we have B intersecting with C, we can see that there's no 2 in either one, there's no 4 in either one, but they both have a 6. Oops, I'm writing in white. They both have a 6, they both have an 8, and so the intersection would be 6 and 8. Okay? Intersection of A and C. 1, 2, 3, 4, 5, 5, 6, 7, 8. The only member in that set is 5. And now, the way we do this one, first we have to find the intersection of A, B. And we have to write down what's in that set. What's the intersection of A, B? We have a 2 and we have a 4. That's 2, 4. And then the intersection with C is 5, 6, 7, 8. And remember, when we're talking about intersection, we're looking at commonalities. So what do they have in common? Nothing. And so we say that that is an empty set. And the way we write that is we use a symbol. We can use the braces with nothing in it. We can say the word empty set, or we can put a 0 with a line through it, which basically means null set. Any of these four will work when it is an empty set. Braces, the word empty set, the word null set, or a 0 with a line through it. Okay. Now, the next type of operation that we do with sets are things called unions. Union, we use the U, okay, and this is the combination when we combine. It's either in this set or this set. Now remember, I said that the intersections were and. They have to be in this set and that set. But a union, it can be either in this one or in this one. And so what we do with that union is we put all members of both without writing repeats. So when I make the union of A union B, make the set of A union B, I've got 1, 2, 3, 4, 5. I don't need to repeat the 2. I don't need to repeat the 2. So I just write that 2 once. I don't write the repetitions. And I add 6, 8, and 10. So 1, 2, 3, 4, 5. I don't need to repeat the 2 and the 4, and then I just add. So it's the union of both sets. 1 is in set A or set B. Okay, 2 is in both. 3 is in A. 4 is in B. So it's the union of both, one or the other. B union C. Pause the tape, and I want you to do 2 and 3 and look for the union. List the union. Now check your work. The union of B and C would be 2, 4, 5, 6, 7, 8, and 10. A union C will be 1, 2, 3, 4, 5, 6, 7, 8. Now notice I don't repeat that 5. So when you do a union, you don't list things twice. You only have to list it once. All right, we're going to pass on the Venn diagrams. Sorry about this. Okay, now we're going to use the number lines to represent each set. So if I'm showing all real numbers greater than -4, I would start my line at -4, and does it include -4 in that set? It says greater than, so I'm using the open circle and I'm graphing those numbers in the greater than direction. Now, try letter Y on your own. Pause the recording. All right, so now we're doing all real numbers less than or equal to 1. So I start at the 1. Because it's less than or equal to, I'm making a solid dot, and I'm moving in the direction that they are less than. Now, for the third number line to represent the set, it says all real numbers between -2 and 3. So my question to you is, does that include -2 and 3? It says between. So what kind of circle do you think we're going to write? That's right, you probably guessed, an open circle. It does not include -2. We put an open circle at -2, and we put an open circle at 3 because it's between them, not including them. And we write a line. And only those numbers, that means all real numbers, that means everything in between -2 and between -1 and 0, all those decimals and fractions are included in the number set. All right, so now we're going to move on to one more topic within this. This will get easier. Set builder notation. Set builder notation is just a fancy way to write what members are in a set. Okay? We have two types, roster notation and set builder. In roster notation, that's basically what we've been doing. We list all the members. numerically, okay? With set builder notation, it's what I like to call fancy writing. And the way you read it is X, I'm going to underline it as I'm reading. X is such that, that's that colon there. Sometimes they write it like this. X is such that X is a natural number. Does that make sense? And we also have to write the ending. Now, remember yesterday we talked about number groups, right? So it's a natural number, but where does it end? You have to write the ending point. And X is less than or equal to 5. It shows the boundary. So X is such that X is a natural number. What group are they part of? Right here, that's the natural numbers. And my boundary is 5. X is less than or equal to 5. Since 5 is in the set, we have to add that equal to. Okay? So now let's try some set builder notation. Okay, X, this is the roster notation. Now for set builder, we're going to say set B is equal to, we're going to say X is such that, these are what kinds of numbers? They are natural numbers. And now we're going to have to show both boundaries. So we know it's part of the naturals. X is and X is greater than or equal to 4 and less than or equal to 7. You can write it as an in-between, or you can write the word and. Now what this really means is this. This is what we call an in-between statement. That means X is greater than 4, and I don't need to rewrite X is less than or equal to 7. Notice the arrows are going in the same direction, so I only need to write that X once. Another way to write that would be X is greater than or equal to 4, and X is less than or equal to 7. So you could have written it like this, or like this. This is what we call an in-between. Now, pause the recording and write these notes. Rewind it if you need to. Okay? Okay, next group. Now they want us to just use roster notation. So what would be the roster notation for A? And remember, the upside down, not the U, is the intersection. We said that an intersection is only what they have in common, the commonality. So in this case, A intersecting B is only what they have in common, and that would be 4 and 5. Okay? And A union B is the combination of both. When we put all members together, we combine them. We make a union. It's like a marriage. What is in A or B? And we don't write the repeats. So 1, 2, 3, 4, 5, 6, and 7. Okay? Pause the recording if you need to take notes. All right, so now here's really where our lesson is going to begin. This is what your homework will be like. I have to pause it for a minute. Pause the recording, turn on the air conditioning. All right, so state the domain of X in roster notation. When they say, look at these directions, guys, state the domain. This is something we're going to hear a lot this year. All this is new language for you. So if you need to repeat the video and take notes, go for it. But, you know, it will start to become very familiar. I know it's uncomfortable to begin. Now, this is very important. Notice that A says roster notation. If you mix this up and put roster notation under B, I will mark that wrong on a quiz, so you've got to keep that straight. Remember, roster notation is just listing the numbers. So on A, we're looking at whole numbers, and it has to be less than 5. So I'm saying X is a member of, the way we read this is X is a member of or is an element of. It has to be a whole number and is less than 5. So when I look at that, I'm doing what are the whole numbers? Where does the set begin? X is, so we would do 0 is where our whole numbers start, and we do 1, 2, 3, 4. Since it's less than 5, 5 is not included. Now, the way we write the set builder notation, I know this sounds complicated, but it's so easy. You just really copy what's written there. So we're going to write. Now notice, we're just copying, and you just have to add the X is such that. X is such that, you can even write the line. I like to write the line. I don't know the PowerPoint. X is a whole number. You're just copying this. A whole number, and write this in inequality form. And X is less than 5. So you're really just copying that. Now, let's look at number 2. X is any integer between -3 and 2. Does that include -3 and 2? So in my roster notation, because that's A, I'm going to list -2. It has to be an integer. -1, 0, 1, and I don't list 2. Now in set builder notation, if you want, pause the recording and see if you can get it right. All right, now check your work. X is such that X, remember, just fancy writing, and I'm going to copy it. X is an integer and X is greater than -3 and X is less than 2. Close the braces. Is there another way? Do you guys remember how to do that in-between statement? You take the smaller number and put it here. I could have written this right down here too. Smaller number, bigger number. We said X has to be less than 2, but it's greater than -3. So I could have written that like that as well. I don't need to write both. I could write this, or I could show it like this. Okay? Now, why don't you pause the recording and try and do number 3. All right, so it's a natural number that are less than 7. So in roster notation, it's 1, 2, 3, 4, 5, and 6. Close the set builder. Close the roster. In set builder notation, now, would I include 7? No, because it's not less than. Okay, in set builder, we're doing X is such that X is what kind of number? Is a natural number. And X is less than 7. Now, the reason why I didn't need to write the beginning, the ending part, that it starts at 1, is because saying it's a natural number, the natural boundary starts at 1. Okay, so it's kind of like by saying it's natural, it starts at 1. So this is set builder and roster notation. This is what most of your homework is tonight. All right. So when we use the sets below to find the following in roster notation, we're just listing. So remember, the upside down U is an intersection. So they're saying A is any whole number, B is -3, -2, -1, 0, C is 1, 2, 3, and 4. So the intersection of A and B, what they have in common, any whole number, and B is just what's in set B. What is in A and B? Oh, sorry, whole numbers start at 0. So the only one that they have in common is the 0. Sorry. I was looking at C. Does that make sense? Because in whole numbers, they end at 0. Remember, our wholes are 0, 1, 2, 3, and so on. Move on and on. So then we look at B union C. Why don't you pause the recording and try all of these? All right. B union C would be -B, -3, -2, 0, 1, 2, 3, and 4. Can 0 be negative? No, it can't be negative. They just put it there to trick you. All right, so what is in B or C? It's a union. B intersecting C, what do they have in common? Is there anything in common? It's all negative numbers in B and a 0, and all positive numbers in C. So this is what we would call our empty set. There's nothing there in common. A union B, the only whole number, no, it's a union. I have to combine them, so it's -3. We can actually start with all of B and then write ... We can show a little bit of the whole numbers, and we have to show ... to show every whole number that's included in the set. Now, A intersecting C, every whole number. So really, our whole numbers start at 0, and we're looking at we're not looking at the union, we're looking at only the intersecting. So that would really be everything that's in C. Only what's in common, the commonalities. So intersection is an and. So it's only the sometimes, let me go back here 1 minute. Oops, that's not what I wanted to do. Okay. Part of what we can do is right at the end. Another way to write this. Hold on, let me just go. Another way that we can write number 5. Really quick here. Sorry. Obviously, it's not quick. Okay, and one more way that you can show, since if you notice that the intersection is everything that's in C, I could have also written C. Okay? Those are the members. That's another way we can show it. So that is your set builder and roster notation. Remember, roster is just listing the elements. Set builder is writing the group they belong to in words and writing the inequality. Okay? Let's take a look over here one more time. Remember, we're really just copying the rule. We're really just copying the rule every single time. You see, when we write set builder and we add X is such that, fancy talk, set builder. It's a whole number, and I turn this into the inequality. Here's the integer. I have x is such that, and I write my in-between statement. Or x is greater than -3 and x is less than 2. Here's the rule. And I've got my inequality right here. So that's your set builder. And remember, this is your roster. Don't mix those two up on your quiz or you won't get full credit. Okay? That's 9-1.